Welcome to this specialized module on information systems operations, with a focused deep dive into IT asset management. Managing the lifecycle of your hardware and software assets is not just about keeping an inventory list. It is a critical security and cost control function. Today, we will explore the lifecycle of IT assets, from acquisition to secure disposal, ensuring you understand the governance and controls required at every step. Let's get started. Let's begin by defining IT asset management. It is more than just counting computers. ITAM is the business practice of managing the financial, contractual, and physical attributes of your IT environment. Why do we do this? To optimize costs and manage risk. If you don't know what you have, you can't secure it, and you can't patch it. The scope includes hardware, like servers and laptops, and software, including licenses and cloud subscriptions. Governance is key here. We must identify the owner who is accountable for the asset's value and the custodian who takes care of it technically. Without ITAM, organizations face shadow IT risks and expensive compliance fines. This flowchart visualizes the ITAM structure. IT governance sits at the top, mandating the IT asset management program. This program splits into three main categories: hardware, software, and information assets. Notice how all three categories feed into the final outcomes: security, cost control, and compliance. If you neglect any category, you fail to achieve the outcomes. To manage assets effectively, we must view them through a life cycle. It starts with Phase 1, planning and acquisition. We don't just buy things. We justify the need and select approved vendors. Phase 2 is deployment. This is where we tag the asset, physically and digitally. Phase 3 is operation. This is the longest phase, where we patch, maintain, and monitor the asset. Finally, Phase 4 is retirement. This is critical for security. We must ensure data is destroyed before the asset leaves the building. Managing this entire cycle prevents zombie assets that consume power and licenses, but provide no value. Here is the asset lifecycle. We move from planning and acquisition on the left to deployment and tagging. Then we enter the operation and maintenance loop. Finally, we reach retirement and disposal. The arrow loops back, because the disposal of an old asset often triggers the planning for a replacement, keeping the cycle alive. Let's focus on hardware. You cannot manage what you can't find. Inventory control is paramount. We use RFID tags or barcodes to give every device a unique ID. We must track location. Is the server in the London data center or the New York office? We also track changes. If a technician adds RAM to a server, that change must be recorded to keep our configuration baseline accurate. A major challenge here is shadow IT devices users bring in without permission. Effective hardware management involves scanning the network to detect and block these unauthorized devices. This flow shows the hardware intake process. We start with a physical asset. We ask, is it tagged? If no, we apply a unique ID. Once tagged, we scan it into the inventory. Crucially, we then assign a location and an owner. All this data feeds into the asset database. The final step is the periodic audit, where we physically verify that the database matches reality. Software asset management, or SAM, is often more complex than hardware because software is intangible. It revolves around licensing. We must respect the End-User License Agreement, EULA. If we install 500 copies of a program but only paid for 100, we face massive fines. Conversely, if we pay for 500 but only use 100, we are wasting money on shelfware. SAM helps us optimize these costs. We also maintain an approved software list. If a program isn't on the list, it should NT be on our network. For software we write ourselves, we manage the source code as a critical asset, often using escrow agreements to protect it. This diagram illustrates the SAM balancing act. We perform a software audit comparison. We weigh installed copies against purchased licenses. If installed is greater, we face compliance risk and fines. If purchased is greater, we have wasted budget. The goal is the green box in the middle, the optimized state, where what we use equals what we bought. We must also manage the data itself. Information asset classification is the process of labeling data based on its value and sensitivity. Common labels are public, internal, confidential, and restricted. Why do we do this? Because security is expensive. We should waste resources encrypting the cafeteria menu, public data, but we must encrypt credit card numbers, restricted data. Once classified, we apply handling guidelines rules for how to store and send that data. The data owner, usually a business manager, is responsible for deciding which label applies to their data. Think of classification as a pyramid. At the bottom is public data, requiring low control. As we move up to internal and confidential, the controls increase. At the peak is restricted data, requiring maximum control. The higher you go up the pyramid, the stricter the security measures must be. The cloud changes everything. Cloud asset management is difficult because assets like virtual machines can appear and disappear in seconds. Physical tags don't work here. We need API-based tools to discover what we are running. The biggest risk is sprawl servers that are running and billing us but aren't being used. We also face huge security risks. A single misconfigured storage bucket can expose all our data. Finally, shadow IT is rampant in the cloud because anyone with a credit card can start a server. We must implement strict monitoring to detect these unauthorized assets. This flow shows how we manage the cloud. The cloud account is monitored by a discovery tool. It checks the asset status. If an asset is active and tagged, it is managed. If it is active but untagged, it triggers a shadow IT alert. If it is idle, it triggers a cost waste alert. This automation is essential for cloud governance. The most dangerous time for an asset is when it leaves. Asset disposal requires strict sanitization. Simply deleting files isn't enough. They can be recovered. We use 3 main methods: overwriting, wiping the drive with random ones and zeros; degaussing, using magnets to scramble the drive; or physical destruction, shredding it into pieces. As auditors, we require a certificate of destruction as proof. Also, don't forget the hidden hard drives and office copiers and printers. They retain documents and must be scrubbed too. This decision tree guides disposal. When retiring an asset, check the media type. If it's a magnetic disk and we want to reuse it, we use a secure wipe. If not reusing, we degauss or shred. If it's an SSD, wiping is different, so we use crypto erase for reuse or physical shredding for disposal. All disposal paths must lead to a certificate of destruction. Finally, how do we audit this? Our goal is to verify the inventory is accurate. We use 2 main tests. Floor to book means picking a random computer in the office and checking if it's in the database. This tests completeness. Book to floor means picking a record in the database and trying to find the physical machine. This tests existence and finds missing or stolen items. We also review licenses to ensure we aren't under-licensed, legal risk, or over-licensed, wasted money. These audits protect the organization from financial loss and security blind spots. This diagram contrasts the 2 audit tests. On the left, the completeness test moves from the physical asset on the floor to the asset register. On the right, the existence test moves from the record in the register to the physical asset. Both tests are required to achieve a verified inventory.